Good afternoon. This is the CNCF Cross-Cloud CI project introduction. This talk is going to be a high-level overview of everything related to the Cross-Cloud CI project. Let's go ahead and do this here. I'm Watson with the Cross-Cloud CI team. Today we will go over why we're here and what the Cross-Cloud CI project is all about. We're going to take a look at some of the technology behind the project and review what we're planning to do in the future, and then we're going to have a QA session. All right. This is the Cross-Cloud team. We've got Taylor and Denver, who co-founders for the CI Working Group, as well as the Cross-Cloud project, and that man sitting in the back row there is also a co-founder, originator of the Cross-Cloud project, this hippie hacker. It's me on the API development for the project, and Lucina for the product owner. The reason why we're here is because the CNCF is growing. They're across the board, they're adding new cloud partners, new integrations, new projects, and we have a goal of trying to show interoperability between all the projects and how they work with all the cloud providers. This project's trying to meet that goal. Cross-Cloud CI is a complementary CI system. We're in the middle ground between your CI system of your project and then your CD for going to production. We fall in between those two systems and we don't replace either system. We have created a complementary CI system that is composable. We can do builds, provisioning of Kubernetes with integration tests, and we also have a status repository and a dashboard. And the status repository is an API that gathers results from the different systems, and the dashboard shows those results. What we're wanting to target is all the CNCF projects, which is a lofty goal. We also want to target some projects that are not CNCF, but the Linux Foundation, like ONAP, which is a networking project. We also want to target all of the cloud providers that are part of the CNCF. Right now we support quite a few. We also support Packet for the bare metal, and we also have OpenStack as a target. Now I'm going to show you the dashboard itself. Down the left side here, we have the projects that we support. There's also a bunch of, this is a subset, there's a bunch more down, but it's cut off. Across the top, we have Kubernetes, and this is also showing the clouds that are supported, so AWS and Google Cloud. We also have a Packet for the bare metal, and then OpenStack supported. This stable and head release for Kubernetes shows or displays here, and then you can see the behavior when we grab the Kubernetes source and build it and then deploy it on each one of the clouds, what's happening. So on the IBM cloud, so there's a failure there, and then there's successes. So this is what the cross-cloud trigger client looks like. It is a just a one-liner, this build project here. There's also a provisioning command, and then a app deploy command. And so it's very simple. This is what the configuration for the project looks like. It's a YAML file, and what we can do is configure some of the elements for the actual project, like where the logo is going to be. Some important things would be the stable and head tags or branch name based off of the whatever it is that the developers decide is stable or head. And also an important thing is the timeout. So some projects take a longer time to compile or deploy, and we have a timeout so that we don't have to keep retrying. Cloud configuration, dynamically configurable. You can decide on the dashboard what's going to show, which cloud, what order, and the display name. And then how the dashboard updates. So when the dashboard or when the build is going or a provisioning is happening, the dashboard dynamically updates and it shows or goes from running to success to or failure based off of what stage you're in and what the backend is doing. All right, and then there's also other things that you can do on the dashboard. You can click on the badges for the build and see the build job within GitLab. You can also click on the provision badges, and it'll either show you if the provision failed or if the app deploy failed, and that will show in GitLab. All right, so there's 3 components within the cross-cloud CI, and these components are the build pipeline, the cloud provisioning, and the app deploy components. These are different parts that are all composable and optional. Each of these creates an artifact such as binaries or environment configuration that has a pinning between all the different pieces. You could specify different versions of software, projects, or Kubernetes by enabling various different flags, and that can help you to debug different problems. Now, the build pipeline stage is your traditional compile, and that gets everything together as the artifacts. We create pinning files and put everything into a container that's pushed into a registry that is available to use. We either build a source from the different projects, or we'll pull artifacts from an external system. If the project already builds artifacts and creates containers, then we'll integrate with those and validate those containers. We do that with the ONAP project, and they have a Jenkins build that actually creates an upstream container that we use instead of building their source. For the cloud provisioning stage for Kubernetes, we take all the Kubernetes artifacts and we provision them on the cloud providers. We allocate actual VMs or the hardware with Packet, whatever we need to use to provision Kubernetes. Then we move on to the next stage, which is the app deployment. And for the app deployment stage, we run end-to-end tests for the projects. We use Helm to deploy all of the projects. The back-end platform handling the workflow and the runners is GitLab. In GitLab, you can see the pipelines kicking off based off of the cross-cloud API client that starts the deployment. It takes the artifacts from the builds that were previously run from the environment. So, for instance, like Kubernetes will create artifacts, and it will use those and start provisioning them. In the case of ONAP, when we do app deploys, cross-cloud goes into the Nexus registry that ONAP provides, and it downloads their containers and then uses the Helm charts that we maintain with them for the app deployment. So, as a technology overview, we use GitLab for its runners and its ability to mirror repos within the runners and workers. We use it to trigger the underlying items like Terraform for the cloud provisioning. This is where we come in and allocate the resources on all the cloud providers, and it makes it real easy to maintain a large set using the community maintained modules and instead of doing it ourselves. Cloud init is where we pass all the metadata, and then we create the manifest for Kubernetes and lay everything down on the disk. The app deployments, again, are using Helm. We always use upstream end-to-end tests, and as much as possible. Sometimes those are in container. So with ONAP, they can actually have their own set of containers, and then we start specifying what we want to run in them to run their tests. The dashboard is Vue.js, which is completely configurable on what projects we show or not show. The status repository is Elixir Erlang, which interrogates the different CI systems, and you can also push information into the status repository from the trigger client. We've been around for over a year. In last February is when we started, and what we did is we started to demonstrate GitLab, and we used some of their pipelines in front of a bunch of different CI working groups and things like that, and got feedback from the community about what they wanted to see, and it ended up being the dashboard, or something that ended up becoming the dashboard. We then had the dashboard released in January. That was shortly after the KubeCon Austin. We also did a pre-release at KubeCon Austin. Since then, we've been adding a bunch of projects like ONAP, OpenStack. They were pretty cool because those are different than your standard clouds. And also there's the external integration with the CI of ONAP. In July, we implemented VMware as a cloud, and that was unique because it's the first time that a cloud provider did the implementation or helped us with the implementation. And then we implemented Envoy in September. Here are some of the projects that we're wanting to add next. Us as the cross-cloud team, we may add them directly. We may also try to engage the community to have them add themselves, just like VMware essentially added themselves to the project. We're looking to try to engage the community more so that they can maintain their own projects, have the cloud providers maintain themselves. ARM support is also a thing that is probably going to come by way of packet. Probably the biggest thing that's going to come up next is external API access. The API is public right now, but we've got a lot of feedback on how users would want to query the API. And one thing would be, for instance, querying Prometheus and its behavior on AWS for all of the stable releases, and then using that like a flag for your internal CD to go ahead and push something to production or not. And so that type of thing. Also, being able to push information in from other CI systems is what we're looking at as well. So things other than GitLab. We have some integration for Jenkins, but some of the other things like Spinnaker. So on the main dashboard, we'll go back. Another thing that we were wanting to do was add a project like how Kubernetes here is unique. It's at a top layer, and really if Kubernetes fails, then nothing else should be passing. Another thing that we would want to add maybe would be Rook in order to monitor, say, storage or maybe core DNS, and have those have the same type of privilege that Kubernetes does on the dashboard, be a top layer, and we would be testing interoperability there. We also want to be able to push more information from other CI systems or systems that we already have access to. So for instance, for ONAP, we have access to Jenkins right now, but we're only grabbing pass or fail. There's other information that we can probably get from that. So we wanted to increase that. And then we're collaborating a lot with the community to try to get feedback, because this is a complementary CI system. It's not a replacement for your CI. It's supposed to work with existing CI that already has existing end-to-end tests. A lot of what we do is help to make your internal tests more visible and validated externally. This is in contrast to a user knowing how you internally set up your system. So as a user, if I want to download and use your software, if it's supported on cross cloud, I have an extra data point on how it's supposed to work. So we're working with various communities like Prometheus and Core DNS to try to create more end-to-end tests. Hopefully we can use their efforts to maybe add in performance testing. Another set of communities that we're heavily involved in now is the networking community, so Network Service Mesh, OpenCI community, and OPN NFV. And then there's a CI working group that happens the fourth Tuesday of every month. And in December, we have another intro and a deep dive. Deep dive is going to show project maintainers how to add their project to cross-cloud. And I think now we can open it up for questions. This is how you can reach us. Anything? No? All right, thanks.